Hello everyone, I am Pratibha, final year civil engineering student, Faculty of Engineering and Technology, Khwaja Muddin Chisti Language University, Lucknow. And my group members are Miss Chandprabha, Miss Priya Singh, Miss Sapna Singh, and Mr. Rajat Saxena. I am going to keep a seminar presentation on major project, a experimental study on interlocking Lego brick using fly ash, cement, and stubble. A project submitted in partial fulfillment for the award of the degree of Bachelor of Technology in Civil Engineering under the guidance of Engineer Kaushik Kumar Saha, Subject in charge, Department of Civil Engineering. So let's get started. This is our content. Introduction. What is Lego brick? Objective, history and background, model and its size, and material used for brick, manufacturing of brick, sample, benefits, obstacle during manufacturing, testing and result, cost analysis, future enhancement, conclusion. Now will we know what is Lego brick? We all know brick is a building unit in form of rectangular block. The volume of construction both in the private and public sectors increase annually. Therefore, building materials become more and more popular, the manufacture of which are on the move and constantly offer all new types that are significantly superior to the main characteristics of their procedures. One of these materials is Lego brick. So, what is Lego brick? Lego brick is known as the interlocking brick. Interlocking bricks are an improved form of traditional clay brick. Each brick is designed to seal itself to other surrounding bricks without the use of mortar. Automatic locking is achieved using the sear key and the lock mechanism. The traditional clay brick and Lego brick are shown in figure. Objective. What is objective of Lego bricks? The use of interlocking bricks can help protect the environment. Not only will they use less concrete and mortar, but building occupants will not need to use as much as air conditioning as the interior temperature is lower. Not only does it cost less to make interlocking bricks, but it is also required less effort and fewer workers. No need of skilled labor. Durable bricks so require less maintenance. History of Lego brick. The history of interlocking brick started in the early 1900s with the construction of toys for children. Lego started as a carpentry in the 1930s when Ole Kirk established a shop to manufacture the wooden toys. In 1946, the company acquired its first injection molding machine and started producing plastic parts. The interlocking block was first developed by the Highland Institute of Scientific and Technological Research in an attempt to provide a cheaper and faster construction product for the housing sector. Let's know about model and its size. Size of interlocking brick is not specific, so there we are providing size of interlocking brick is 30 into 12 into 10 centimeter. Diameter of circle is 6.35 centimeter and vertically interlocking part is 1.5 centimeter. So let's we know about Lego brick construction material. We use here fly ash, stubble, cement, sand, and stone dust. Cement. Ordinary Portland cement is a cementing material obtained by fine grinding of Portland clinkers with a little amount of gypsum to adjust the setting time and prevent flat setting. And second material is fly ash. Fly ash is the finest of coal ash particles. 72% of India's power plant are coal waste. These power stations generate nearly 40 million tons of fly ash annually. Fly ash contains CO2 emitted from thermal power plants. Industries using coal as a fuel emits unwanted ash and smoke from which fly ash is produced. Sand. Sand is a granular material composed of finely divided mineral particles. Sand has a various composition, but it is defined by its grain size. Stubble. Parali, also known as stubble, is the remains of the crop after it has been harvested. Only the upper section of the paddy crops is harvested when they are full grown, leaving the lower portion unharvested. And next is stone dust. Stone dust is like a coarser version of sand. It is generally the byproduct of crushed stone. The figure of all material are given so. A material which is required for these bricks like cement, sand, stone dust, stubble, is batched and mixed proportionally. It is then compacted to form brick with desirable interlocking patterns. When the required mix is prepared, then brick is compressed properly to achieve its strength. Remove the brick from mold. Air dry for 48 hours. Then for about 7 days, these bricks are subjected to curing. The cement set and bond with sand, adding to the stability of the brick once the curing is done. There is our methodology of construction. Number first, collection of material. After that, batching and mixing of material. Then filling in mold. After that, compaction, demolding, air dry, and last curing. Here is a short video during the Lego brick construction. So let's start. Now we will talk about samples. We took here four samples. Sample number M1, sample number M2, sample number M3, sample number M4. Sample number M1. Fly ash 55%, cement 10%, stone dust 25%, sand 10%. Sample number M2. Fly ash 50%, cement 15%, stone dust 25%, sand 10%. Sample M3. Fly ash 50%, cement 15%, stubble 2%, stone dust 23%, sand 10%. Sample number M4, fly ash 50%, cement 15%, stubble 4%, stone dust 23%, sand 8%. Now we will talk about benefits. Lego brick has multiple benefits. Number first, economical. Number second, earthquake resistance. Number three, better insulation in hot areas. Number four, environmentally friendly, labor shortage, curing faster, and durable and require minimum maintenance. Now we will talk about obstacle during the manufacturing, like collection of material, deciding the mix ratio, difficulties in compaction, use of stubble due to mold, etc. Testing and results. Types of testing. Number first, comparison test. Number two, water absorption. Number three, fluorescence test. Number four, soundness test. Number five, shape and size test. Comparison test. The comparative strength of the brick samples were determined by the following equation. C equal to P upon A, where C is compressive strength, P is maximum load, and A is area of cross section of brick. The figure of compressive test is shown here. This is graphical data of compressive strength. Water absorption test. Water absorption percentage is defined by this formula. This is W2 minus W1 upon W1 into 100, where W1 is dry weight of brick and W2 is weight bricks weight. This is graphical data of water absorption value. Fluorescence test. This is conducted for finding out the presence of soluble salt in a brick. Soundness test. The sound is carried out to find out that a clear ringing sound is produced or not. When the two bricks are struck with each other without breaking any of the two bricks. Shape and size test. Tolerance of brick is plus minus 2 mm. There is the data of shape and size test of Lego bricks. Cost analysis. Cost of brick. Cost of brick is differ because of mixed proportion. Cost is different for each material. Total rate of M1 sample brick is 42 rupees and M2 brick rate is 42 rupees, M3 brick rate is 42 rupees and M4 brick rate is 41 rupees. Future enhancement of Lego brick. Lego brick future enhancement is high because of its multiple benefits like it is fire resistant, it is flexible, high wall capacity, sustainable, sound resistance, easy construction, and headway premium quality. Now we will talk about its conclusion. Ultimately, whether or not interlock bricks are suitable for construction depend on your needs and goals. If you need some save money to build an apartment building in an earthquake prone area, they might be a good choice. On the other hand, if you live in more temperate, yeah, colder climate where earthquakes are rare, ordinary bricks are probably your best option. Although they cost a bit more, they offer better resistance to rain and better weather protection. Accordingly, the concept of interlocking system has been widely used as a replacement of conventional system. It can be concluded that the shape of the interlocking brick varies with simplicity, which result in easy and fast production and assembly in the masonry system. Thank you all of you for listening my presentation.